Hey everyone, I'm Professor Rad, and today we're going to talk about terms in algebraic expressions. And since we're going to be talking about terms, you can see there's a lot of blanks for us to fill in some terms here. So that's a little pun. Ha ha ha. Okay. So let's just define these words and we can talk about what they mean. So a term is an algebraic expression of the form ax to the n, where x is a variable, a is a real number called the coefficient, and n is a whole number. Terms can also have more than one variable being multiplied together. A term without any variable is called a constant term. Okay, basically when you have an algebraic expression, remember that if you're translating and you have multiplying, you don't have to write anything in between those things. So ax to the n means a times x to the nth power. And so you might have, these are like little itty bitty things that are frequently added or subtracted. So these get a name, these are called terms. Ordinarily, instead of having a letter in front of the x, you'll have a number here, and you'll have a number for the exponent. So for example, I'm just going to show you what a few terms might look like. So you might see a term that's like 8x squared. So it's a number and then x to some power. You might also see terms that have decimal coefficients. So something like 5.3 times x, that's another term. Or you could have a term without a variable like 4. This would be called a constant term. Or you could see terms that have more than one letter. So you might see negative 2xy squared, right? So this term has two variables with it. It's got an x and a y. Or you might see something like 15m squared n cubed p, right? So different kinds of numbers, letters, exponents being used. But notice there's no like adding or subtracting here. So a term is just a number with a bunch of letters, perhaps some exponents. So again, in each case, the term has a number in front that we're going to call the coefficient. You could have any number of variables with or without exponents. So like here, this x, I didn't add an exponent on it, although there's a secret exponent of 1. Remember, when there's no exponent, secretly 1. And we're multiplying that together. Now, two terms are going to be called like terms if the variables are the same and the exponents on the corresponding variables are the same. So all of these terms that I wrote up here, none of them are like terms. For example, these two, the 8x squared and the 5.3x, they both have x's. But notice that the exponent on this x is a 2, and the exponent on this x, which isn't written, is just a 1. So even though the letter is the same, they have different exponents, so they're not like. Even the negative 2xy squared and the 5.3x are not like, because even though they just have like x's, this one here also has a y squared, and this one doesn't have a y squared. So again, they are not like. So in order to be like terms, not only do you need the same letters in play, but the exponents on those letters have to be the same as well. So let's look some more examples of terms and like terms. Okay, so in example 14, we've got this algebraic expression, 4x squared plus xy minus 3y squared, and they want us to list the terms and state the coefficient. Now, terms are those like little short bundles that are being added together. So for example, we've got this 4x squared. That's our first term. And the coefficient, that's the number that's in front of the term. So the number in front is a 4. Now, terms are things that are being added. So the next term here is a positive xy. Ooh. Now, when you have a term and there appears not to be a number there, there is a number there. It's 1. So you might want to make like a little note to yourself that if you have like xy, that means the same as 1xy. So the coefficient is 1, it's not 0. So if you just had an m, that's the same as 1m. It doesn't mean that m is 1. It just means it has a coefficient of 1. Kind of like if I said, oh yeah, I ate 1 bag of candy. Well, that doesn't mean I ate 1 candy. It means I ate 1 bag of candy. You don't know how much was in the bag of candy. So it doesn't mean m is 1. I've just got 1 of them. All right, and then the last one here, remember, terms are things that are being added. Remember that subtraction is addition of the opposite. So if I have subtraction here, I'm going to keep that as a negative here. So subtracting 3y squared is like adding a negative 3y squared. And so the coefficient is this negative 3. So when I have an algebraic expression and I'm trying to identify the terms, I take any operation like the addition or the subtraction that are joining them, and I take the one that's in front of it, because that's going to tell me whether the term is positive or if the term is negative. And again, the coefficients are just the numbers that are in front of the variables. All right, so now let's try and identify some like terms. So, which of the following terms is like the term 15x? So the first thing I do is I look for matching variable. So anyone that doesn't have x or has any letters other than x is not like. So 15, it doesn't have an x, so it can't be like x. xy, not allowed to have y, because all we have here is an x. And then we have 4x. Then this x has an exponent of 1, right? It doesn't have an exponent written on it. This x has an exponent of 3, so it's not like, it has a different exponent. This one is like, because there's just a 1 here, an invisible 1 on the x, and the only letter there is the x. So those two are like. Let's look at part C. We want which of the following terms is like the term 7m squared n. So I'm first going to narrow it down. I can only have like terms if there's both m's and n's present and no other letter. So this one we've got an m present, but there's no n. We've got m's and n's, m's and n's, and n, but no m. Now I need to pay attention to the exponents. So when I have the m portion has to be squared. So the m has to be to the second power. On this one, the m doesn't have the exponent. The n does. So this one is not like. Here the m has the second power, so that part's good. And now we're going to look at the n component. So the exponent of 1 for n, and there's only an exponent of 1 here. So these two terms are like. Now, I like this example in particular because they do sort of look unlike, in the sense that the letters come in a different order. So this one is m squared n, and this one is nm squared. Remember that this all means a bunch of multiplying. 7 times m squared times n. And when you multiply, you can shake up the order because it's commutative. So if I wanted to, I could rewrite this as negative 2m squared n. I can change up the order of the variables when I'm multiplying them. So now these two look more similar, okay, or more like. So oddly enough, the order doesn't matter, but the letter matters and the exponent attached to the letter matters. That's how you can identify your like terms. So I have a few now you try problems for you to work out. In the next video, we're going to be taking these like terms and combining them to make complicated looking expressions less complicated looking. So I'm looking forward to seeing you then. In the meantime, have a fabulous day.